Okay, I think it's up and running. So welcome everyone again. This is already the third part of the series of tutorials that I'm going to do for the RISC-V integration, and this is for actually trying to understand how to integrate a RISC-V processor, the ones that are actually done in Chisel, and executing instructions inside of them in both simulation and FPGA. So right now we are focusing in the FPGA. I would like to focus more in the FPGA as it's more real to work with, because all of the tools are already done. Is very relatively easy to implement a processor and execute instructions from there. So then again, I have explored a little off screen the FPGA that I have in mind. That is the ULX3S. It's a lattice-based FPGA, and I run some examples here and there. And my intention is to convert this into a game console if it's possible. A very simple one, maybe. For now, I'm just trying to create a microcontroller. So in the last session, we actually make this using IntelliJ IDEA to explore the core and actually integrating the RISC-V console platform that we are going to use from now on. So right now, I see that that is not pushed yet. So I'm going to push it like very quickly. Let me just do it. Let's go to the RISC-V console. And let's see here what is happening. I have a lot of things here and there. Just another system app, something like that. Oh shit! I need to revert that. I screwed up. I think it's not checkout. I think it's reset. No, I totally forgot. Screw it up. That's what happens when I don't check the files that I'm going to push. Revert to previous commit. Like always, Stack Overflow actually make us. Wait, I already put reset here. What is this? Maybe I'm going to just edit the git ignore. I'm going to ignore everything that is named generated SRCs. Let's see if this is just enough. Okay, status. Let's check the log. Yes, get commit. Sorry, get commit and RBC. What was the comment that I actually put? This one. Get push origin master. Sorry for that. I totally forgot to push the data before, and maybe it's okay if I just do it like this. Right now this is supposed to be okay. Yes, supposed to be okay. So let me brief you. So we created this RISC-V platform that is the module itself that we want to put, and that's pretty much it. It will have a number of GPIOs just inside here that it will be created from the configuration of the GPIO key. It will instantiate the lazy module. It will instantiate the module as well. We will get the module as well, and do the RISC control that we actually had a little trouble with. And what else? The debug connector, yes, that for now is tied off. The GPIO and the UART connections, that's pretty much it. We can activate the JTAG also, so we can just put the JTAG there as well. So let me see where we can get this. So as long as I am aware, the bug is just at the bug IO, and the bug IO actually has a lot of parts. We can put the JTAG inside there as well and maybe taste it, but I don't have a JTAG here right now, so I will do that in a future process. But we need to connect this. So the JTAG is actually a JTAG IO, and the JTAG IO is practically this. The JTAG with the reset, the FPGA, the part number, and the version. I am almost sure that this is connected to this MFRD, the part number, and the version is because it's a port, is already connected in some way before. And if I tie down, maybe it's okay. Maybe it's the same. I am not sure. Connect the plug and reset. The JTAG is here. The MFRD is there. Okay. So it's not connected at all. If I do the tie off, or if I do the if I use the connect debug, it will use the configuration that is saved in JTAG DTM key. So we can put that in a configuration file, in a configuration class, and then we can export the JTAG. It's just that simple. But this will connect the JTAG using a simulated JTAG, and we don't want that. We want to just exteriorize it. So let me see what we can do. We can literally just connect the JTAG if we want. Right now, what is the configuration of the system? So I am using the JTAG DTM. So it will create a JTAG if it's enabled, but we are going to do it enable for now. We don't want a soft core right now. We want something real that we can actually work with. So what I'm going to do is to actually just export it. I'm going to just export it, and that should be okay. So the JTAG is already declared here, no? Inside of periphery? No, the debug transport? Yes, this JTAG IO. And it's composed for these systems, that is the TRST, the TCK, the TMS, the TDI, and the TDO. So whatever is here, I'm going to do it. So we are going to assume that that exists. So we are going to choose create it. Create a port. So what is the name of the stuff? System JTAG IO. So JTAG is equals to new JTAG system JTAG IO. And we need to we don't need to actually declare if this no, this is the system JTAG IO. No, we need only the JTAG IO. Sorry. I'm going to import it, so I'm going to import it, and we need to have the reset there, but the reset comes from the configuration actually. So the configuration there's a configurations, put this in false by default, so we shall put it also in false as well. Yes, that's literally what we are going to do. So we have a JTAG here, and the next step is just to connect it. So this will connect the backlog, and the debug is different from the DTM, the debug transfer model. So the debug transfer model actually is what the name says. It will just transfer whatever is inside of the JTAG to the interface of the DMI. DMI is the debug model interface. The debug model interface is actually a bus that can be any bus to actually issue the comments. Only issues the comments to read and write some registers there that will also be affected by the processor, as long as I'm aware. So one is to connect the debug model, that is the DMI. Then we can connect the JTAG to the outside. And because we use this, maybe it's safe to assume that maybe if we do sys.debug.get, that we are going to assume that always exists the debug model for now. The system JTAG, yes, we get this as well, and we get the JTAG, and we are going to connect this to our JTAG using io.jtag. Very simple. We need to connect also all the stuff that is here. So for example, get, and for example, the MFRD, the part number, the reset, all the stuff. We are going to put, I'm going to put 0.u on all of them. But if you must, you should put it in whatever position you want to put it. The part number, that is also something. Get that, and the version, that is supposed to be also there. What about the reset? We need to put the reset in some way here. Let me see. If they do the tie off, it also creates that thing. We shall put JTAG reset here. So in order to do that, I think I am going to export this in true actually. So it has a TRSTN, but then I will connect it to the reset of this the bulk transfer model. So it will have the reason put there. It has a reason, no? How they connected? As a single resin? Oh, okay. So I shall use it. I shall need a single resin. Maybe it's from a library. It's from the GSO tree. Wait, what? Ah, okay. It's because it's some model. Okay. Now I get it. Okay. Because they put true. Maybe this is negated. We shall negate it. Maybe. Not sure. Not entirely sure. This reset is active low, active high. I don't know. Because it's a normal reset, maybe it's active high. So I'm going to negate it. Something like this. That should be okay. Okay. That is good. That seems good. And we can put it also in another port if we want. So doesn't matter. I'm going to create this port again. So I am going to create this thing again. After this, we are going to create the FPGA shell. So that is the third step. I actually forgot to update the steps. The text that are beside this camera here. Sorry, here. I forgot to change it the other time. So in the step 2 is already done. That is generated the Verilog file and the Verilog files that we shall need. Okay, so okay, TIO driver I think is connected backwards. Maybe we put it, or maybe I needed to put it flip it. I needed to put it flip it. That means that maybe I need to put this opposite. Maybe the FRTL will trigger. Anyway, as I was saying, I forgot to change the stuff. So right now we are in the step 3. We are going to do the FPGA shell. So let me define you the FPGA shell. We are going to grab this platform and we are going to connect it to the FPGA in some way. The shell is supposed to not change at all, and it's going to have all the connections possible to that specific FPGA. That is a shell, and wherever you put there, it goes to the shell. Okay, The to reset is missing, so I needed to put in another port. Doesn't matter, you can put it. Can put it here. Can put this in false. Can put this here with IO. Come on. Perfect. I am going to make sure that that also the VRTL doesn't get totally screwed up. Let me put this a little zoom here because yes, it's a little same for this one that I'm going to use it a little afterwards. Let's say the VRTL fails. Yeah, I'm certain sure that it's not going to fail. Okay, perfect. So from now on, we are going to create the rest of the stuff. So we are going to create here in our project in our RISC-V console. I'm going to create another folder. Oh, they call it here packages, but it's a folder that is going to be the shell. So I am going to create here a file that is going to be named ULX3X ULX3S. Okay, so we have here this thing. We are naming here everything RISC-V console, so we shall name it also RISC-V console dot shell dot ULX3S. Okay, we have this. So we can just create the class, name it ULX3S shell. That extends a raw model. So the difference from raw model is actually that the model always will create the clock and the reset, and everything gets deduced from there. So if you create a register, it will have the clock and the reset associated to that clock and reset from the context that is the model. But now in the raw model, no clock and reset exists. The only way to put registers and stuff, you need to contextualize them first, and this is useful for creating any kind of wrapper that you want to do, what you want to do for the whole system. That means that the top that we are putting here is the one that is going to expect to be compiled with the same ports and everything. So everything is going to have the names that I want. Is not going to be IO underscore something like it happens in the regular models. No, we can put whatever names we can, and the ports that are going to be here, no other port are going to be created additional to that. So it's very useful for that kind of stuff. So we are going to create the raw model, and exclusively for the raw model we are going to have I think I already have here some of the stuff for the ULX3S. So right now what I am searching is, well, we have here the manual of the ULX3S that has all the connections and stuff. I have read it a little. The constraints, that's what we need. Then the board printout is here. So the thing is going to be here. I actually had it open in another folder. So everything that is connected to the as a constraint for the IOs are totally being here. So what we are going to do is to practically replicate this into the shell. We are going to put exactly the same ports, the same everything, and hopefully everything shall be okay. So component, so it seems to be a clock. So we are going to put so val, we need to have this exact name, and that is an input of you need to grab everything in IOs. IO of input of bool, no, sorry, of clock. So this is a clock of 25 megahertz. This thing, and this other thing. Okay, it's good enough. I don't know what is this. Disable slave port disabled. Locate COM, FTDI, RXD, TXD, and RTS. Okay, so we shall put them as well. So val FTDI RXD. For now, for this tutorial, I'm going to just put what I think is necessary. I'm not going to put absolutely everything, because if not, this tutorial is going to be long, very long. IO of input, maybe it's an input of RXD of bool, and the same ones for the bool. TXT of the output. Perfect. It's supposed to have here an RTS, an NDDR, and the TDXT enable. We shall put them as well. Wow, I don't understand this. It's a little... What about for external JType programmer, the GPIO, what is this? For example, RXD or TXT, no. Doesn't say anything. No, this is... It says there is a Cerdus one. I mean, this can be RTS and the yeah, the RTS and the DTR that is supposed to be always true and always false, I think, for doing just regular stuff. We shall ignore them, but maybe it's going to have problems. Okay, I put it there as something to do. Yeah, obviously we are going to put some LEDs here. And because the way that we are going to create them, we shall need a vector of inputs. I wonder if you can we need to make the whole thing input and or output. I don't quite remember, but I'm going to put it. No, I'm going to create the vector. The vector of I don't know how many elements. 8 of output of book. Those are the LEDs. Those are the next ones are the buttons. But those are not outputs. Those are inputs. What else? Switches. We have 4 of them. SPI OLED display. Nope, we don't need that right now. SPI flash. Holy shit, they have a flash here. Okay. The SD card. We shall connect this afterwards. The ADC SPI, the 4-bit DAC, the Wi-Fi ASP32, the PCB antenna, the second USB port, the ASP. Wow, they have a USB 2 here. Oh yes, indeed they have. They have a transceiver there or something. Holy moly! They have a they have a. We shall do a USB the implementation maybe. ESP USB, SD-RAM. There's a lot of SD-RAM stuff. GPDI, GPDM, GPIO. What the hell is this? Default GPIO, default single-ended. GPIO run, GPDI, shit. Physical connector when finely angled solder, when male vertical soldered. Pins number are GP and GN. To enable differential, please rename LBC mouse 33 to LBC mouse 33D. To enable clock IO, you need to put that is something like that. There's a lot of them, but everything can be resumed for this too. That is just a 28 stuff, so we can just put them. Well, okay, we can put them. GP, that is a vector again of we are going to just not put it as an input. Those are analogs. Those are analogs, or 1 of W. So, okay, we have 28 of them. So 20F of them will be GP and GN. Perfect. We have GP and GN, a lot of them. Program N, the reload bitstream for flash, exit bootloader, the shutdown power. No idea. Okay, that should do. Then, okay, we have this. There is a dedicated port for the JTAG. No, I'm going to put that as well. So where's that port again? I saw it before. Sorry if this is too slow. I mean, we are doing everything from scratch. I don't have any experience with this FPGA. I don't have any experience with actually doing the stuff here. I have quite experience with the RISC-V stuff. That's why I'm telling you this, because most of the questions are like, what do I do? Where do I start? What to do to actually implement all this system into my FPGA? This is the reason why I'm doing this. So if it's a little slow, sorry for that. But yeah, you can always skip some of the video. Anyways. Continuing, so we shall find a dedicated JTAG. It was a dedicated JTAG, or it was. Let me see if I can find a JTAG here. No, they don't have anything like that. We shall put them into another stuff. Maybe a random port in this side ports maybe. That should do it. Okay, let's do it like that for now. So for now, I think this should be enough for this tiny bit. Okay, the LEDs are outputs, the BTNs are inputs, and the ACD, the SW are also inputs as well. We shall not change this, but some of we shall put some of the GPIO actually inside of here. So we can just put this again big. Then we can start to do our stuff. So we are going to put here FPGA. Fuck you. I actually needed a package FPGA. So we are going to create here a file and it's going to be named ULX3S Scala again. But this is different because this is I mean this was the shell, but the other one is going to be not the shell but the FPGA implementation. Understand? The one that actually is going to carry everything. The shell is not supposed to change, so maybe for another kind of designs we shall put it there. If other people wants to connect it in another fashion, but the shell is not supposed to change like at all. Actually, in a future tutorial that we do in the shell, we are going to put here. Actually, I'm going to put it as a to do. Put the PLL. We haven't put the PLL yet. For now, we are going to use this system clock, and we shall use some of the switches for that. By the way, it's supposed to have also some switches here, like button 1 and button 2, F1 and F2. Where are those? Okay. Up, down, left, right. Fire 1 and fire 2, and the button power N. Okay, we can use the power N to actually just, because it's just a power, supposed to do power, we shall use it for the reset. And we are going to do exactly that. Yes, so we shall put like this class ULX3S top, maybe extends the ULX3S shell. We shall import this, the shell. So it's just an extension. So I'm going to put here well, clock equals the clock 25. So clock 25. The valve reset is going to be the power, the PWR. That is the button of 0. So is PTN of 0, and we shall put it that is inverted logic. And we can we shall put with clock and reset. That is a chisel tree construct. Clock and reset with the clock and the reset. Maybe it was like this. Yeah, it's perfect. With clock and reset. Then we shall go and instantiate the platform. That is going to be the module of new RBC platform. Not imported yet. There's no implicit p parameters, so we shall put them implicit p parameters. Is from the chips alliance rocket config, so it's there. And now it's time to connect everything. So platform, the GPIO. So how many GPIOs do we have here? We have 8. We shall need 8 for the LEDs and 8 for the buttons. But we are using the buttons already. We shall use only maybe 6 of them. So 8 and 6 are 14. And we can then we shall put more if we want. So for now it's 14. So it's a little hard coded. I mean, it's not going to cover all the cases, but this is a good representation that you want to do. So we are going to put this here. Platform GPIO, the IOFs, the pins. Pins of 0 maybe. OI and stuff. Oh, okay. So we shall put it there. You can get this. This is an enhanced pin, and the enhanced pin can give us an output pin that it will put a signal, and an input pin that will have the eyeball, but they don't have a maybe the base pin has something. Input pin, output pin. No, nothing like that. So don't be confused. This function and this function and everything that is inside there is when you already have your pin defined and you want to control it, but no for getting the values. So because we are using this and the GPIO is supposed to have that already, we shall get the oval for the LEDs. So we are going to do this. Okay, we shall put this in this way. For example, LED zip platform.pio.pins, and maybe we shall get a range. How do I get a range of this? I am not sure. Oh my god, I am a little scarce with the expressions here. The range is a range of the numbers that are going to be created. Maybe if I put from to. Okay, maybe this one. Slice. I always forget it. Sorry for that. So we should put down the pins at the slice from 0 to 8, but it will include that. If I put from 1 to 3, it will put 1 2 3. Okay, so it won't include that one. So if I do this, should be fine. Should be fine. So for each one of this stuff, actually we are going to name it AB. Okay, case AB. The hell. Okay, the actual lead is going to be L, and the pin will be the B. So lab L dot L will be connected to pin dot O and the oval. Perfect. For security reasons, maybe we shall put it ampersand with pin dot O dot output enable. So if the output enable is not enabled, it will always output 0, for example. So this is a simple and that will do that for us. We can also I mean, this will put it in pure logic, but we can also use the buffer that is specially designed for this kind of I/O. But I am planning to use those for the external I/Os. For now, I'm just going to use logic here. And we know that the oval is going to have the output value of the GPIOs, and the EOE is the other one. Then again, it's going to be like that. So for the buttons, according to the documentation. Here the buttons have fire 1, fire 2, up, down, left, right. So buttons are not 6 actually, are not actually 8, they are 7. So I made a mistake there. So buttons are not 8, are 7. So I can rename it later. So everything that is btn dot slice of 1 to 7, set with platform dot GPIO dot pins dot slice of 8 from, so there are 6 of them. So 14. But for each, 14 for each case B pin is going to be the opposite. So the PTN the B will be assigned to pin dot E dot idle. And the shabit. So we can put this into our random stuff. So for GPN GN, we are going to just put it into, I mean, those are analog stuff. Ah, shit. Okay, those are analogs. What do we do? Okay, we shall use this the thing about the shell. So I'm going to put this here. I'm going to name it the lattice library, because I don't know how to name it. So package RISC-V console dot shell dot lattice so import obviously chisel 3, and so I have read a little about some kind of stuff here that is about the ULX3S, and it's the FPGA library reference, and there's this stuff here that is the CMOS 6 milliampere bidirectional output buffer. So those are the connections, so we shall put it there. This has it has also one with the pull down and the pull up. It's impossible to control the pull out and the pull down. I never saw an FPGA that can support the pull up and the pull down stuff. It's totally impossible, actually. So yeah. So we are going to create that kind of stuff. So everything about this is black boxes. So class BB extends black box. So I need to create the bound IO of this. It's like a regular stuff. So IO of new bundle. It's IO of new bundle. Then we should put here all the ports. So according to the reference, it will have TIOB. So TIOB. The B is the one that is supposed to be analog, the one, the W. So this is actually an experimental. Yes. Not found. Raw T, that is input of, it's an input. Yes, it's an input. It's an input of bool. Same for the other one. So I for here and O for the other one. Perfect. So this will have some helpers here. They actually have helpers in the in the original shells. This is actually an idea from sci-fi. I am not doing anything special here. This is from there. So we can def as input something like this. As an input, it will return always a bool, and it will return the bool, the boolean that you want. So it will connect T to always 0. It will always return IO.O, so it's there. Okay, as input. Sorry. no, as input, so it will always return this, and I need to turn off this stuff. Okay, and just for security I just put the I into false.b as well. As output, and we'll have the signal here, and this doesn't return anything unit. So here it will put this as a true, and the I will be the O, but B no, only O. That's enough. Now def from an answer, and we'll spec an answer pin here. So E as a type of an answer pin. So we need this to be import. Again, this doesn't report anything, doesn't return anything. And we shall connect everything as intended. So IoT is supposed to be the control of the answer pin, and E dot O dot the output enable. The input enable doesn't matter. The IO dot I will be the E dot O dot over. Then IO dot the IO dot O will go to this. So E dot I dot IVO will be the O of this. That should be enough. Actually, it doesn't need the next pin because it's just a base pin actually. So the base pin will be perfect. So if anything, we need to just convert it to a base pin, then pass it through this stuff here. This will be used for later. We are going to we only invented this because we needed to put something into the JTAG, so sorry for that. We should put also the attach from, attach to, maybe analog. So there is an attach or analog to IO.B. Perfect. So this will connect the physical stuff. Okay. ULX3S. So here. So we need to create our stuff. Yeah. Also, I forgot to put a little here about the object bb. The dev apply will be to create this. What else do we need to do here? Okay, so we shall also do the lattice lib, import the lattice lib, then create our stuff. Okay, but maybe an apply also that we have the analog. Analog, and we'll create the bow. And this will do like instance again this of model of bb bb dot no m dot as input, no, as output. Oh no, sorry, as input of, and we need to attach it as well, so and attach to analog. Perfect. So again, if they bring us also the ES as a bool, that means that is another stuff, but it's not, it's an unit here. So it will instance this, then attach to analog, but it will put it as an output of I. Then again, def another apply here that will have something like this actually. But instead of an bool is the E for enhance for base pin. So it will create this, but it will do the from enhanced of E. Actually, this is supposed to be named base. Okay, perfect. Now, so we shall put it there. So PTN. No, sorry. Lattice lib. Okay, so we need to do BB. BB of so GP of 0. We are going to put here the platform.jtag.io.jtag. TDI. Wait, I need to accept TDI. So it's not an output, it's an input. So we shall put it here, and we assign it here, and we shall create all of that. So the GP0, the GP1, the GP2, and the GP3 will be otherwise TMS and otherwise TCK. Now TDO is the only one that shall be do here. TDO. No. Now what about the TDO? Is not a. It's a new 3 state. Fuck me. Data undriven. Okay, data and driving is high C when it's low. Okay. So it's not like this. I need to convert this into a base pin. We shall use the base pin of sci-fi. Then we connect to TDO as intended. Okay, why is not what the hell? Is an extension of the pin. As a base .o the open enable is the plan for the DO that driven. So according to the description of this, active high when it high C when driven is low. Okay, so it's literally the open enable and data. Now DDO as base .o oval is going to be the same platform but the actual data. Perfect. Then we totally ignore the TDI, the input val, and we do this as the base. Perfect. And we connected the TDI. Now we shall connect also the reset of the JTAG. So I am going to put it, and I already occupied all the buttons. I'm going to put it in one of the in the SWs. So something like this. Platform.ir.jtag RSTN is going to be SW of 0, maybe. Perfect. And with this we have everything up and running. So from now on we can create this ULX3X stop instead of the other one. So let me go to the stuff here, to the RISC-V also. Then we are going to do the variables here. Variables. Yes, variables. Here. So it's not anymore that this is the ULX3X top. Although we shall do it one for this stuff. Maybe we can do this as for that for the simulation, if we are going to do one. So okay, the project is still the same, but this is name and the model is console, and also top. The Verilog model is also the same one, and model package RISC-V, so FPGA config package, and the generator is the same chip here. test driver, and at the top is the RISC-V platform, or the RISC-V system. Perfect. You're ready. Let's see if but here it is, makefile. We shall also define. Is by default created here? No, and we need that the sub project is not RISC-V console. For this specific one, the sub project is going to be the ULX3S. Make default. Whew, and this should be enough to actually have that kind of stuff. So that was a thing. Difficult to do. My God. But as you saw, it's just a matter of creating the shell. The shell is going to have the ports, and the ports is going to have that. So it doesn't get the ULX3S stop. Why? Not there. Is the ULX3S stop. Extends the shell. Okay. Then what? Where is trying to get it? The RISC-V console.fpga. Wait, what? Name this. Top model is this. RISC-V console.fpga.ulx3x. Okay. Maybe this is not necessary. Only FPGA is enough. Okay. Sorry for that. Let's do it again. That creates the design. Does stand, then fails because we connection between sync, that is, and the source, that is the reason IO in the RBC platform saver. Okay. Okay, RBC platform in line 30. Okay. Why? Okay, the sync is reason 0 in this RISC system, and the other one is a reason. Sync is IO, and the reset is a reset. We shall do it without a reset, maybe. No, but it gets instantiated here, so it's not going to change anything. What should we do? We can just connect it here as a bool. I mean, that should change it, but I'm not sure why it happened. Weird stuff that this kind of thing happens. These things happens all the time. I wonder if it's going to pass. I'm not sure. Okay, but it's another. Sync is unavailable. How many GPIOs created? Supposed to connect to create 8. GPIO 00 pins 8 eyeball. The eyeball is not created for the eyeball. Wait, the eyeball? From 8 to 14. And the error is in the ULX top. Sync or source unavailable in current model. So sync or source unavailable. Sync or source unavailable. Slice 107 zip of this for each for B pin, and pin.i.eyeball. It's not available. I don't get it. I don't get it. I literally don't get. I did not get that one. So I get this from the number of GPIOs on the GPIO key. So this is supposed to be 8. But if it was an error of execution, the execution should trigger an exception here. But the execution is not. This is not the execution. This is something else. This is a chisel exception. And it fails on the on the 24. It's definitely failing here. Sync or source. I'm going to put in fast B here. In that way we can discard that is the source of the sync. We have 1 hour and a half. So it's what I suspected. There's not enough. There's not enough. So is the eyeball the problem? Is the GPIO the problem? Is there something there that I am not taking part of? Not sure what is happening. So GPIO and the new non-set pin. I mean, the GPIO.pins are just the non-set pin, no? Yeah, it's supposed to be the non-set pin. And this got created here, and in the platform we created like this. I mean, it's got created in software here, then in hardware gets connected here. We get the GPIO port IO, then the GPIO pins, and go to the GPIO port IO, and I just connect P with A. Not sure what is happening here. Let's read that error again. Sync or source not available to current model. It's not available. It's not available the model. Let's do it again. Alright, I am not sure that it's going to fail. If I don't, maybe the configuration, but I already replaced this. Okay, if I am not putting anything sufficient into the stuff, maybe we can put this like 13 and it's going to fail, but the exception is going to be different. It's supposed to be different. No, it definitely gets. What if I just ignore this? It's going to let me create it? Because it only happens with the 8. What happens to the other 7? The eyeball is not going to be there? But we already created the model at that point. But it's not available. It's not available. What is that? Stop messing around. Just work. You're supposed to work. Okay, something weird happened there. So I'm going to inspect the Verilog, the generated Verilog file, because I don't believe it. I mean, probably it's going to trigger the error in the VRTL stage. Maybe it's void. All the eyeballs are voids. Reference 6L is not declared. It's a little weirder right now. Okay, we can just put this inside of here. Maybe that's what happened to the GPIO. That it was not created the module before. Then it was lazy and it was not available. I mean, it's a possibility, but what is that? I don't know. Sometimes this weird thing happens, and that's why people prefer to go to system Verilog. References is not declared. References is not declared. References is not declared. What the hell? What the hell just happened? Okay. Doesn't matter. We are playing with hardware here. We always expect that the tools are not that one. That sharp. Don't worry about it. We can always fix this. Come on, go there. sys.gpio.thing. Okay. The sys is not declared because the bus is here. What about the sys? Sys is a RISC-V system. But this is another top. So sys is not declared, and indeed it's not. It's a RBC platform and it gets there. Okay, that's what happened. That happened. So it's a bug. It's basically a bug in this kind of stuff. This gets named sys for some reason. Look, when it goes to the I/O bound and connects this, it gets named sys all the time. ULX1925. So actually it's supposed to be named RBC platform, and that's all. So if we force a name, if we force a name it sys maybe, that should be fixed, but it's a workaround. Come on, come on, come on. Pray that this happens. Please give me a good VRTL. Give me a good VRTL. I'm not going to close it because I am almost sure that it's going to change to get false again. What the hell happened? What the hell happened? What the huh? What the what? There is a lot to unpack here. Usually one error will get the other ones in order. So I don't usually. So what happened here? So oval and OE from GPIO 0.0 pins. It says that that this kind of stuff is totally not there. It cannot infer the type. And it says also that oval and O and everything gets accessed from a non-bundle. Then says here then illegal or non-vector type. There is a lot of actually stuff there. I wonder what happened. I mean, there is a lot to unpack there. Don't get it a lot. Maybe it's because we choose the development version of Chisel, because this is internal, but we can fix this and maybe do some kind of stuff to actually circumvent these kind of errors. But right now, I mean, what they did do for the chip here actually. If we go to the build.sbt, they have, come on, give me Scala. If we go here, the chisel, where's the chisel? Chisel is a projecting file of tool chisel, and we put it as well. I just said it's just that one. It's a projecting file of hardware chipyard tools chisel 3. It's the same one. No, this is another error that I don't know. Uninferred type. Uninferred type. Uninferred type. We show we shall extract it from here. I mean, trying to get the RISC-V platform that is up a little upside, then get the GPIOs. RISC-V platform output I/O is GPIO. GPIO is a flip eyeball on event A, event I. Oval is UINT, OE, IE, POE, DS. It's a 13. It's a 13 vector. I should put it to 14. Okay, the config first. I'm going to put this on 14. Then oval. GPIO. But it doesn't get triggered from this system, and this system is you know, I am going to name it maybe different. Maybe it's a fluke. Yeah, maybe it's a fluke. It's a possibility like everything else. So I'm going to name it differently, and we are going to see if it's something like that related there. What the hell happened? Not sure what happened. This is the first time that this happens to me. This kind of incomprehensible errors, I think, is the reason nobody uses G-Cell. I mean, not literally anybody. I mean, the other hardware groups. Let me brief you a little about my thinkings about RISC-V. I think RISC-V is a good ISA, but I have seen some people that actually think that RISC-V is not the best way to go for some kind of stuff. Yeah, definitely something's happening there. Something that I cannot control. First, this is not declared. Well, as I was saying, some people are trying to be disbelief about the future, about RISC-V, that because I mean, I think the people is a little too conformist, because the ARM already exists, and what is the name of the other one? I forgot the name. Well, that processor from Synopsys, that is very little, and it's good for low power. It begins with A, but I don't remember the name right now. Maybe I'm too concentrated with this, and I don't know. Well, it's just that every processor and every ISA that is already out, they already have a purpose, they already have a meaning, and if you want something in low power, then you use that one. Then if you want an Android based computer, you use ARM. And then if you use if you want a high yield stuff, maybe you can go to ARM, or maybe you can go to Intel. And yes, I mean, great, but I just thought when I was doing some kind of papers, they actually say people that is very important in that kind of stuff, that RISC-V is not the way to go for doing low power. That kind of sticks with me, because I have seen actually low power implementation of the RISC-V already with the serve, for example. The PQRV is actually a very good example. Power wise, not energy wise. But for energy, you can do another kind of tricks that is not inside there. And my criticism with all the stuff is actually what I base my master's degree within is the way that the processor is presented. Everything is totally obfuscated, totally mysterious, and you don't know the internals of what is happening. With this, I can boost open everything. With this error, I can eventually find it and totally fix it. That kind of stuff. I can do all that kind of stuff. I mean, fairly easy, without too much trouble. And I definitely don't get it. Why the people are a little too skeptical with that? I mean, it's important people, so you always listen to the important people, because unless you can demonstrate them that you can do or you cannot do, they are going to still to be to not move their thinking beyond that point. And it sticks me. It sticks me actually. I don't conceive that you just don't accept anything because it's already everything invented. The way that all totally got advancing is because people actually break through with other types of stuff, and that was because they try something different, in my opinion. It's a little sad. It's just my opinion there. I know that maybe nobody's listening right now to me, but that's what I think. Yeah, that happened to my during I was with writing a paper. The paper was to what? The name of the conference was CICC. I actually got rejected. I mean, I know that maybe I am too much to actually try to get something into CICC. Try my best, but it's difficult. It's difficult. You don't have a lot of tools to work with. When you do it, you need to break through in a manner that actually is very difficult to do. And you need to write very specifically what you want to present to those people in order to convince them about an idea that you have. And yeah, no novelty, no kind of stuff. They always bring those kind of things. Yeah, whatever. Anyway, Let's continue with this. I am suspecting that the error is actually related to this slice. If we don't use the slice, maybe we can make it without too much trouble. So if we actually comment this and maybe we put true.b, not false.b, I think it will be good to go. If that is true, maybe we cannot use this slice. The reason maybe we cannot use that slice is because maybe they kind of wrap those kind of functions we work with, and until they don't have it actually implemented inside of the abstraction of the chisel or FreeRTL or whatever, is not going to work. So maybe it's a report to do to chisel. I don't report my pull request. I always think that that's not a problem with me. I always think that my observations are not worth the time with, because I don't know, people are a little too very hard to convince, and that was in many times my downfall. Anyways, let's continue with this. I am just bluffing here, bluffing nonsense. So this is probably going to pass more certainly, because definitely the GPIO is not going to be there. I mean, unless they have something like this bullshit here. Type mismatch, TLB reset, the cache, the content, the crocodile, the whatever. Okay, so what if we do, don't know, maybe if I don't do it as an async reset, please let me do it. Anyway, if we cannot use this, then we need to do something hackish, something like a for I in 0 until 8. Maybe we can do it like that, something like this. So let of LED of I will be the pin that is a slice of our pins of I, this and this, and this is not here. Sorry, this was IO.lit. No, it was LED. LED. It was LED. Okay. That of I. Okay, I forgot this. Okay, perfect. Put on, and then this one here. Maybe it's because it's not ready there that maybe that thing happened. If we do this again from 0 to 7 to 0 to 6, maybe we can do it like this. Okay, perfect. Maybe this is okay. just what I suspected. The IO also I need to put it. So IO dot. So if I do this to the IO I need to actually put it into the I.IO. I need to put it in some kind of stuff there. You know, I actually think that this creating this kind of thing is actually fun. When you create some kind of stuff that you do from scratch, it's actually very how I say, it's very fun to do. You grab your code and you code your code and do whatever with that code, and it's going to be it's usually very fun to do this kind of stuff. I like to do this more than actually investigating stuff. When you do investigation, you usually need to do a breakthrough, and those breakthrough actually break your spine. Anyways, I'm going to cheat this. We are going to go to Sci-Fi Freedom because this thing is not going anywhere. If I do that, the A300, and we go to the platform that they have some kind of pin generation here, and they generate the pins from this kind of stuff. So the actual UART, for example, where's the UART? Okay, they actually use pin generation for that one as well. Wow, they have a lot of pin generation here. We shall do it. Pin generation here. Yay! So we cannot do this. We shall do it like this. So let me understand this code first. I get the sys UR, the sys PWM, the sys whatever, and then I connect everything here to the GPIOs. The GPIO pins go here. Okay. IO pins GPIO. So IO pins GPIO, what is this? GPIO pins of pin gen. Okay, we can just copy and paste this. I mean, I don't actually care. So what about the UART TXT and the RXT? We can do this as a new base pin. Because it seems like everything is going to be exported or imported using BasePin. It's going to be like that. Then again, can be wrong. SPI doesn't need it. The UART, so they get the system UART, the system whatever. I mean, you can just get it. It's just GPIO. I mean, we can just get it. Yes. I mean, they don't do it like that. They did like GPIO pins from port. They use this thing. You can just put it here. I'll resolve it because says GPIO, IO pins GPIO. Because IO is IO.GPIO. This usually doesn't work. I mean, not in this perspective. And this is not the result of any pin mask because we are not using pin masks. The UART. So the UART code is actually here. We can just they create a wire, but we don't need wires. Where we go? Where we go, we shall not need wires. The hell? UART pins set 6 UART of UART pins port. What? Okay. So it creates because it can create several UARTs. That's why. But we only need one UART. So if we are going to do that, pin gen. So map C wire of new UART pins and new UART pins. New UART pins. And they do UART pins from port. Okay, there shall be a UART pins. So we shall not need this. Instead of this, we can do a new UART pins where we can do what this expect a pin gen. Okay, so if it expects a pin gen, I shall do this. Okay, UART pins actually is a pin gen of UART signals, and UART signals is RISC-V, TXT, and the CTS and the CTN. Okay. Then we shall use these UART pins for port. That's all. That's all that we need. Okay. I wondered why it didn't work. Clock, reset. Parameters R. Okay, R is not, it's UART. UART pins from port is an apply about pins of UART signals. Sorry. It's a UART signal, so this is the port actually, UART. And R, what was R? According to this, the R was the actual UART. So this is IO.UART, and this is the actual UART. Clock to clock, reset to reset, sync stage 0. It doesn't have sync stages anymore. Clock to clock, reset to reset, sync stage in 0. Perfect. So that shall do it. I am not sure what is not happening. I mean, why is triggering errors in the syntax, but this kind of stuff will always do it because they don't typify this good enough. But then again, this is old stuff. Reassignment to vol, yes. I mean, I am not reassigning this thing. Then this thing needs to be a little different because that is not anymore. So let I is going to be a platform Oh wait, I'm an idiot. I am a stupid. Why I am? Why am I so subnormal? I totally screwed up here, guys. Sorry, sorry so much. This totally, I did not see this coming. I totally did not see this coming. I don't know why I did that. Yes, the problem was because I was doing I was totally referencing the internal value. Sorry. No. I did not do it correctly. GPIO O.val. GPIO is an unset pin, so it's O.val. So maybe this will work. I'm going to reduce it. Sorry. I'm not going to. I make the people that the very low people, the people that barely watch me. I made I made their time actually go to fucking waste. I am so sorry about this. I did not see this coming because I did not use the I/O because I was actually that. So yes, so this is IO.pin. No, this IO.GPIO. Slice was 14, and if I connect this correctly, it's going to happen. Oh my god, this is embarrassing. This is totally embarrassing. That's why I don't get to publishing important things. Well, errors can be made. We shall remember always the difference between screwing it up and science is actually documenting it. I'm documenting this so you don't get in the same stuff. If you do a module, you need to always use the ports in the I/O. Yes, it's totally going to work. Oh my god. This is embarrassing. This is totally something that maybe any people just doing a regular digital systems course can detect. Well, shit. Okay, so we actually forgot to put the GPIO 0 to 7 the eyeball because it has to have an eyeball. So pin.i.eyeball is supposed to be false. Because we are not getting anything from the LEDs, and that shall do it. That was all the troubles. Yeah, it was not supposed to be difficult. The difficulty about this is just creating the actual shell. If you do the shell and you already have the module and the module was actually creating the Verilog, this is not supposed to have a trouble. I should do this also with a written documentation. I mean, not anybody is going to just sit down here, listen to me during 2 hours and 11 minutes already. The tension. Wow, minus 30 decibels. My computer is on fire right now. It's on fire. It's on fire tonight. On fire tonight. No, it's going to pass. Yes, totally. Unless I screw it up in the shell. But I don't think so. Okay, I screwed it up in the shell. It says here that the RXT is not connected, not the IE for the T19. What the hell? I think it was this thing. This oval, this maybe supposed to have an IE. TDO as base of I or IE. No, maybe it's O.IE. Yes. False.B. Then we need to connect the stuff that we were missing. And we are good to go. Platform.io UART, and the transmitter stuff we go to the U. What is the name actually? Sorry, I forgot. The share is here. So we actually go to the TXT for this one. Same for the other side. Okay. There you go. Okay, perfect. Now it's going to lower into the other one. Maybe will work. Maybe we just need a pray here. Come on, give me a Verilog. Give me a Verilog after all this work. Give me a Verilog. Come on, give me a Verilog. Don't be a bad program. Please give me a. They give it to me. Yes. Finally, we have a Verilog file. Oh my god, that was difficult to do. Wow. Let me tell you that was not easy to do. Nothing about this is going to be easy. I mean, I was creating a system on chip is not going to be easy in any way. Even if you do it with Verilog, or maybe you do it in a system Verilog, or you do it with this way in Chisel, or do whatever, is going to be always a nightmare. But I always think that this is the way to do it actually fast. I mean, compared, for example, to do it with only Verilog, compare a system in 2 hours and 17 minutes is not totally slow. I mean, we compiled this actually in record time, and this is going to work definitely when we pass it through the FPGA flow, possibly. I mean, at least it's more reliable, in my opinion. So if you see the harness, we can see that actually we have our stuff, like we put it in the raw model. So there's the clock, there's the FTDI, whatever, there's the LEDs, there's the buttons, there's the switches, there's the GP, and there's the GN, and we connect everything that we need, like this. And there are the PPs, PP. Then we put that, then we put another thing here. Yeah, from 7 to 0 is the LED, so they always read 0. And for the read values of the buttons, they always put the button 1, button 2, button 3 until button 6. The TCK, the TMS, the TDI, there's TN. Everything is in order. Then this got totally assigned to the BB, and everything is okay and up and running. And we have some memories here as well. There is a top memories, and those are the memories that are going to be created. You can replace these memories with actual memories that came from the FPGA, but I am more sure that it's not necessary to map it to the actual, because it gets compiled from the system, so it's okay. So let's wrap up. I mean, let's wrap up this. First of all, because I forgot the other time to actually push the stuff, I am going to push it again. Keep status. I'm going to check. I'm going to check the files that I'm going to check to push. So make file, this thing, this other thing, this other thing, this other thing, this other thing. Okay, perfect. So git commit. And we can put here that the shell of for the ULX3S FPGA is done. Put it into master, and we have our stuff. So let's wrap up. What did we do? So we created the shell. We created a shell that is this. This is supposed to have all the ports inside of the FPGA that we are going to permanently use. and this is the equivalent of the path rig, for example, in VLSI. So those are the inputs, the outputs, whatever clocks you have, whatever the FPGA has as ports, or the board as well. We use that shell as an extension to create our top, and then we assign a clock, a reset, and with clock and reset we actually instantiated the platform. And the platform, we connected the LEDs, we connected the buttons, we connected the JTAG, we connected also the UART, and we connected the JTAG of the reset of the JTAG. We also exteriorized the JTAG because it was not created before. To do debugging in the future. So in the next video we shall do the pass the Verilog's that gets generated here through the FPGA flow. That is relatively easy to do because you can just grab, for example, the F files. So this is the list for the file for the top, and this is the list of the files for the hardness. So for the hardness there is anything, and for the top is this plus R reader. So you add those files, you add the files that they are named top.v and .hardness.v, and you put that to synthesize. So you can literally do it right now, but I mean, it's not, the runtime is already 2 hours and 22 minutes, so we shall not go to that through that. This is intended more like a class, so it's only 2 hours. It's intended to be only 2 hours. But yeah, you put that into the synthesizer, then you put that into the stuff, and the same configuration file that is inside of here is intended to work. Maybe modifying the LED and the square parenthesis 7 and transform it to LED underscore 7, LED underscore 6, LED underscore 5, and so on. Add to this shell to actually work, because that is the way that the BEX gets created. We shall do it also with the square stuff, but it is more difficult to actually do it. The abstraction to do it in a Scala is a little difficult to do, so we shall not do that. So that's pretty much it. So thank you very much for the people that actually got stuck into this class. I am going to update here that now the FPGA shell is totally done. So it's like that, and we can put a check on that one. The next video will be the pass through the FPGA flow, and hopefully that will only use maybe 2 hours as well. I mean, when you do it with the flow, is always going to be difficult. So as a little homework, you can try to generate these Verilog files, and with the modified with a modified version of that and of this constraint file, you know, with the underscore instead of the parentheses. Try to get the FPGA up and running. And right now, there's something that is not going to work. That is there's only one missing module, and that specific module is related to the ROM that we haven't. The boot ROM we haven't put inside there. So there is supposed to be here a rom.conf file around here. Yes. So this is my boot ROM. There should be a module named my boot ROM with the module implementation and everything. of whatever code that you want to the core to actually execute first. It can be just a jump to for example to the RAM or something different, but that module needs to exist. And because it doesn't exist right now, it will trigger maybe that the module doesn't exist. You can put maybe 0 there. I mean, the only thing necessary is to actually just compile it into the FPGA for now. You don't need to actually make it work, because the insertion of the RISC-V code inside of the actual FPGA, we will do it in the final in the final step of this RISC-V integration group of steps. Doesn't mean that this series of videos is going to end, but at least this part will be end in that 5-step. So that's pretty much it. Thank you very much again. Share the video if you like it. Don't subscribe if you don't want to. I mean, I usually just a boring person playing maybe some video games and doing this kind of stuff. For now, this will be only the Indian tutorial of this RISC-V integration. Except that I'm an Indian, I don't have Indian accent, so that is a plus. I mean, maybe without offending, no, the actual Indians. I love you. I love you, Indians. Well, anyways, take care. See you.